The many worlds interpretation essentially states that there are countless other worlds that exist in parallel to ours, where nearly all possible outcomes are physically realized. Of course, some things will never happen, such as the violation of physical laws including conservation of charge, mass, momentum, and energy. So for example, a proton can never have a negative charge. This theory was first proposed in a paper by graduate student Hugh Everett in 1957, and although initially dismissed by most, it has gained support in recent years. The theory is based on quantum mechanics and the Schrödinger's cat thought experiment. For some background, the wave function of an object gives the probabilities of possible outcomes, but when observed, the wave function collapses and what is left is what has actually happened. Superposition states that quantum objects can be in two different states at the same time, an idea observable by the double-slit experiment in which a single electron was fired and observed to go through two separate slits. Entanglement states that when two objects interact, they can be described by a single wave function with one wave function having collapsed, and measurement is interpreted as the interaction between two quantum systems, essentially anything made up of atoms. Schrödinger's cat involves the cat in a closed box with a radioactive material, and should the material decay, the cat will die, and if the material doesn't decay, the cat lives. Therefore, the radioactive material and the cat are entangled, and by superposition, the wave function states that the cat is both dead and alive when the box is closed and unobserved, as both scenarios are possible. However, when the box is opened, only one scenario is ever observed at once, meaning when a person opens the box and becomes entangled with the cat, the world has already been split. Specifically, separate worlds split apart when the quantum object, in this case the radioactive material and its detector, becomes entangled with the environment. Atoms of air molecules interact with the box system differently depending on the outcome and fate of the cat, a concept known as environmental decoherence, meaning the universe really branches before the box is even opened. Therefore, one universe will have the person observe the cat as dead, and the other will observe the cat as alive. This prevents the wave function from collapsing, which typically occurs when an observation is made, and instead allows the wave function to split with the unobserved outcome existing in another world. This theory was formed because Schrödinger's equation, which is used to calculate probability at the quantum level, doesn't explain the collapse of a wave function that occurs when the wave function is reduced to a single observation. Under this theory, there is no collapse of the wave function and the equation holds true everywhere. So the many worlds theory says that whenever multiple objects interact and become entangled, every single possible outcome occurs, just in another world that has branched off from the original entangled system. Worlds are not being created, rather the universe is constantly being divided into more and more worlds. Essentially, there is one giant wave function for the entire universe that is constantly being divided. This theory also states that the different worlds can never interact, making it different from the Mandela effect theory, which is based on the assumption that parallel universes have interfered with each other, leading to a disconnect between memory and reality. In addition, the theory also states that there are many different versions of you, meaning once the world's split, one person becomes two separate people who are almost like identical twins. A different version of you that was once identical could eventually come to form different opinions and beliefs than the you in this world. However, there are objections to this theory. Some physicists point out the fact that although this theory was proposed to account for the wave collapse, many worlds interpretation creates new mathematical issues that require further assumptions. In addition, some question what this theory says about reality, as if every outcome is sure to happen, how can one know which they will personally experience? Finally, many question what this theory says about probability, as if every outcome is 100% going to happen in some world. What does the probability of an outcome occurring really even mean? Nevertheless, the many worlds theory holds up mathematically according to Schrödinger's equation, which governs quantum mechanics. Should the many worlds interpretation prove to be true, there is little practical consequence. The worlds are said to never interact, meaning one's choices and decisions and their consequences are essentially still independent to this world. However, this theory gives way to countless interesting hypotheticals. By Schrödinger's equation, any event with any probability greater than 0 is said to occur in some world. That means that worlds exist where the shot heard round the world at Lexington and Concord that started the Revolutionary War was never fired, Abraham Lincoln was never assassinated, and he was the one who oversaw Reconstruction in the South after the Civil War. The Lusitania was never sunk and the United States never entered World War I, and the Cuban Missile Crisis led to nuclear war between the US and Soviet Union, and so on. Regardless of their existence, none of us will ever get to see those other worlds for ourselves.